All right. So today we're diving deep into, this new technique, and it's all about making large language models, LLMs as we call them, better reflect what different groups of people, diverse groups, what they actually want,
Yeah,
which is, when you think about it, a really tough problem, right?
it is. Yeah,
I mean, imagine you're trying to train an AI assistant, like the ones we use every day,
right.
and you're using feedback from all over the world. How on earth do you make sure that it's not just catering to the majority or even,
The loudest voices.
yeah, exactly, the loudest voices in the room? That's a problem with some serious real world implications when we think about AI and fairness and this research. It's kind of sort of blends math and machine learning,
Yeah.
and it really emphasizes this focus on robustness.
Robustness. Yeah, making sure it works well, even in difficult situations.
Okay, so listeners, this deep dive is based on a paper,
Okay.
and it's called Group Robust Preference Optimization in Reward-Free RLHF. Catchy title, right?
It is quite a mouthful.
It is. It is. It was published on May 31st, 2024,
Okay.
and the authors are Shamsundar Ramesh, Yifan Hu, Iason Chaimalis, Viraj Mehta, Pierre Giuseppe Sessa, Haitham Bouamar, and Elijah Bogudovich.
All right.
So if you're following along at home, there you go. That's your reading list. Now, when we talk about aligning LLMs with human feedback, typically there are 3 steps, right?
Yeah, you got it.
So can you walk us through those steps?
Sure. So it starts with supervised fine-tuning, or SFT for short.
Okay.
And this is basically where you train the model on a data set
Okay.
that's relevant to, whatever you're trying to get it to do.
Okay, but what if, and I'm sure you thought about this, what if that data set is biased from the get-go?
That's exactly the problem.
Right.
The data overrepresents certain groups
Mm-hmm.
or certain viewpoints.
Yeah.
The LLM is not going to be truly representative.
Right, right.
And then we move on to reward learning.
Okay.
And this is where you train a separate model to basically predict how humans would rank different responses to a prompt.
Okay, so this is like, this reward model is trying to tell us what a good response would look like, I guess, right?
Yeah, exactly.
But wouldn't a single model struggle to capture everyone's preferences? I mean, what I think is a good response might be totally different from what you think.
That is the issue. Yeah. What one group considers a good response might be entirely different for another group.
Right.
And that brings us to the final step, RL fine-tuning.
Okay.
This is where the LLM is actually trained to generate responses that get the highest reward from that reward model we just talked about.
Right. But if that model's already biased, are we just making the problem worse?
Potentially, yeah, you're amplifying the existing biases.
Okay, so this is where GRPO comes in.
Right.
Group Robust Preference Optimization.
Exactly.
Now, instead of aiming for, the best performance on average,
Mhm.
it's going for the best worst case performance across different groups.
Yeah.
So help me understand this. How are these groups even defined in the first place?
Well, they basically embed group information into the LLM's context.
Okay.
So it could be like explicit demographic labels,
Okay.
or even just a text description of a group's characteristics.
I see. So we're talking about making sure that no single group performs significantly worse than others, right?
Yeah, that's the essence of it. But it gets a little interesting when we get into the math.
Oh,
They use this thing called the Bradley-Terry preference model,
okay.
which assumes there's this underlying reward function
Okay.
that dictates how people choose between responses.
Mhm.
But the key here is that in GRPO,
Yeah.
this function is group dependent.
So hold on. Are you saying that different groups could have completely different preferences even for the same set of responses?
Precisely.
Wow. Okay. So we're really acknowledging that different groups might actually value different things,
Yeah,
even when they're, faced with the same question or the same prompt.
exactly.
That's a big departure from just assuming everybody wants the same thing from an AI.
It is, yeah.
But this optimizing for the worst case scenario, doesn't that potentially drag down the overall performance?
It's a trade-off for sure.
Okay.
And the paper actually addresses that. They introduce this tunable parameter.
Okay.
So you can actually balance the worst case performance with the average performance, depending on, what you need it for.
So that raises some interesting ethical questions, right? Like, how much do we prioritize one over the other?
Absolutely. Yeah.
Okay, so how does the algorithm actually work? I mean, this sounds incredibly complex.
It's an iterative process. So it kind of goes back and forth
Okay.
between updating the policy, which is how the LLM generates responses,
Mhm.
and then updating the weights given to different groups' feedback during the training process.
So it's constantly making sure that no group is falling too far behind. Is that right?
Exactly, exactly. Groups with poor performance in one round get more attention in the next round.
Oh, I see. I see. Okay, but what about groups that have like way more data than other groups?
Right.
Wouldn't their feedback kind of dominate the training process?
That's where the scaling factor comes in.
Okay.
They use a scaling factor to normalize the influence of each group based on how much data they have.
So even if one group is louder, so to speak, because they've got more data, they don't drown everyone else out.
Right,
say.
exactly.
Okay, that's pretty clever. It's like a weighted voting system or something,
Yeah, you could think of it that way.
where everyone's voice counts equally, regardless of how many votes they have.
Right.
I like that. Yeah.
Yeah.
But I mean, this all sounds great in theory,
Mhm.
but how well does this actually work in practice?
Well, they tested it on real world data.
Okay, good.
They used a data set called Global Opinion A,
Okay.
which has multiple choice questions answered by people from all different countries.
Okay.
And they specifically looked at responses from Nigeria, Egypt, India, China, and Japan.
Wow. Okay. Talk about a range of cultures and perspectives.
Yeah, for sure.
So what happened when they applied GPO to this data? I mean, did they manage to bridge the gap between these different viewpoints?
The results were pretty interesting.
Okay.
They found that GPO significantly reduced the performance disparities between these countries.
So it suggests that the LLM could actually be trained to reflect each country's preferences,
Yeah.
even though they're so different.
Exactly, despite their differences.
That's fascinating. I mean, this technique could really be a game changer for developing truly global AI systems, right?
It could be, yeah.
I mean, ones that don't just favor one region or culture over another.
Yeah, for sure.
But we're just scratching the surface here, right?
Yeah, we've only just laid the groundwork.
Okay.
There's a lot more to GPO, and the implications of this research are pretty far-reaching, I'd say.
Well, I, for one, am very eager to dive deeper. So stay with us as we continue to unpack this group robust preference optimization and explore its potential impact on the future of AI. Okay, so we've established that, GPO,
Yeah,
it could potentially lead to more inclusive AI.
right.
And it's pretty exciting to think about like AI assistance,
Uh-huh.
recommendation systems, even educational tools, all being tailored to, different groups' needs and preferences.
Yeah, it's like it brings us closer to that idea of truly personalized AI.
Right.
Like having a tutor who understands how you learn best,
Yeah.
or a movie recommendation engine that actually takes your cultural background into account.
That would be awesome.
Yeah,
But you mentioned earlier that this is just the tip of the iceberg, right?
it is. Yeah.
So what else is there to uncover about aligning AI with human values, especially when those values differ across cultures or demographics?
Well, this research gives us a good framework, but there's still so much to learn about how these differences actually play out in, real world applications.
Okay, so for our listeners who are maybe thinking, all right, I want to explore this GPO thing myself, where should they start?
Well, the good news is the authors made their source code available on GitHub.
Oh, that's great.
And they've also provided access to the Global Opinion QA dataset.
So anyone with the technical skills
Yeah.
can actually dive into the code and the data that was used in this research.
Yeah, exactly.
That's awesome. And who knows, maybe they'll come up with like new applications or improvements to the algorithm itself, right?
Absolutely. The more people working on these issues, the better.
Okay, but here's a question that comes to mind.
Okay.
What about situations where, groups have conflicting preferences?
Right.
How does GPO handle that kind of complexity?
It's a tough one for sure.
It's like you're trying to please everybody.
Yeah.
But what if their preferences are just like fundamentally at odds?
Sometimes finding a solution that truly satisfies everyone
Yeah.
might just not be possible,
Right.
especially when preferences clash like that.
Okay.
But even then, the goal of GTO is to make sure that no group's preferences are completely ignored or disproportionately disadvantaged.
Right. So it's about finding a balance.
Yeah.
Where every group feels like they're being heard and represented,
Exactly.
even if, complete agreement just isn't possible.
Right. It's about fostering inclusivity, even amidst disagreement,
Yeah.
which is, I think, something we should all strive for, not just in our AI systems, but in our interactions with each other.
Absolutely. I think that's a really important point.
Yeah.
This discussion has been incredibly thought-provoking.
It has.
And GIPO, it seems like a real step forward in AI alignment.
Yeah.
But what are the broader implications? What does this research tell us about, the future of AI and what we should be paying attention to as we move forward?
Well, I think GPO is challenging us to think beyond just treating everyone equally, because that's not always enough.
Right.
It's pushing us to really embrace the complexities of human values
Yeah.
and preferences
hmm
and acknowledge that different groups have different needs and priorities.
Like GRPO is teaching us to be more empathetic and understanding, even as we develop AI.
It is, yeah. We need to shift from optimizing for a single objective
Right.
to collaborating and creating AI systems that work for everyone,
hmm
not just the majority.
So moving away from that winner-take-all mentality
Right.
towards a more cooperative and compassionate approach to AI.
Exactly.
Okay, I like that.
Yeah.
But we've been talking about LLMs this whole time. Could this approach, could GRPO apply to other types of...
Oh, hey, welcome. What's up?
Hey there, we are little of small topic. Can we
Okay, you're right. We did get a little carried away there. Sorry about that.
Yeah, thanks for keeping us on track.
You were talking about GRPO in general, and then we started to drift into this other thing.
Right, and we do have more to cover in the paper.
So let's reel it back in and get to that other topic in due course. Okay.
That sounds good.
Okay, so we were just starting to get into how GOPO could apply to things other than LLMs.
Right, that's a really interesting aspect.
Okay, so like imagine a robot that's designed to assist elderly patients
Right.
from, very cultural backgrounds.
Mm-hmm.
Okay, so you're saying that we're maybe getting a bit ahead of ourselves,
Yeah, it seems like we jumped a little bit there.
right? I got excited.
Yeah, you did.
I get that way sometimes.
We were talking about LLMs, and now it seems like you're asking if GPO can apply to, like, all kinds of things.
Okay, so yeah, let's unpack this. We are talking about large language models, but we need to stay focused on the paper.
Right.
And the research we've been discussing, yeah, it's primarily focused on large language models.
Exactly.
But you're right, that doesn't mean it's only limited to LLMs.
Yeah.
It would need to be sensitive to their unique needs and preferences.
Yeah.
Could GPO help train a robot to be both effective and culturally sensitive?
It's definitely a possibility, yeah.
Or think about a recommendation engine.
Mm-hmm.
It's a framework that could potentially be useful in other places,
Yeah.
but it's definitely something we should explore more later. So if you want, let's finish up with this paper. We can brainstorm about other applications later.
Sounds good to me.
So we were saying, could GRPO apply to other types of AI systems?
Yeah, that's exactly what you're getting to.
That suggests, products or services that are actually aligned with your values and ethics.
Wow, so GRPO could potentially encode like values and ethics into AI systems.
It's a powerful concept for sure.
That's huge.
And that suggests we need like serious collaboration
Yeah.
between AI researchers, ethicists, social scientists, all sorts of domain experts.
We need to work together
Yeah.
to develop AI systems that are not only technically sophisticated,
Right.
but also ethically sound and socially responsible.
Okay, so yeah, while we've mainly discussed GPO in the context of LLMs, the core idea is, that it's all about robust optimization, considering group-specific preferences.
Right, that is the key.
They could absolutely apply to other machine learning models as well.
Yeah, the core concepts could definitely translate over.
Think about recommendation systems, for example.
Yeah, that's a good one.
Okay, that's a great point.
Yeah, and this deep dive, it's really highlighted the importance of GPO in this whole AI alignment thing.
Mm-hmm.
But it's important to remember this is just one step on a much longer journey.
Yeah, we still have so much to learn about fairness and representation and values in AI.
Absolutely.
You could use GRPO to make sure recommendations are fair and relevant to different groups.
Yeah, ensuring everyone gets a diverse set of options.
And this idea of group-specific preferences.
Exactly.
That's not just limited to language, right?
No, it applies to all.
Oh, yeah. Uh-huh.
how does it work to the convergence of the GRPO?
Okay, so you're asking how. Oh, go for it.
How does this work to the convergence of the GRPO?
Okay, that's a big question. You're asking about the inner workings of GPO and also how we know that it actually works, right?
Yeah, it's a fair point. We've talked about what GPO does, but maybe not enough about how it does it.
So when you ask about how it works, you're probably thinking about the nitty-gritty of the algorithm itself.
Yeah, like what's the actual step-by-step process to make sure we reach convergence?
Okay, so the paper introduces an algorithm that uses something called alternating updates.
Right, we touched on that a little before.
And basically, it goes back and forth between adjusting the group weights and updating the policy parameters.
Okay, so it's like a constant balancing act, right?
Exactly. Groups that are performing poorly get more weight in the next round of training.
And that weight is determined by the cumulative losses of each group.
Yes, so groups with higher losses get higher weights. This ensures that those groups get more attention.
Okay, and then when it updates the policy parameters, it's also weighted by these group weights, right?
Exactly. The policy update is basically a gradient descent that is weighted by these adaptive group weights.
Okay, so that's how it's making sure that no group is left behind.
Yes, and this adaptive weighting is what allows the algorithm to converge to a robust policy.
Okay, but what do you mean by converge?
Great question. So in this case, convergence means that the algorithm eventually reaches a point where it can no longer substantially improve the worst case performance across all groups.
Okay, so it's like finding that sweet spot where the model is as good as it can be.
Yeah, and the paper actually includes a mathematical proof of convergence.
Okay, so there's some serious theory behind this.
There is, and it is rather involved. The authors prove that the error of the average iterate of their algorithm converges at a rate of OT to the power of -12.
Okay, so without getting into the nitty-gritty of the math, that basically means as the training goes on, the error gets smaller and smaller.
Correct, and the method is guaranteed to converge to a solution, at least in the context of log linear policy classes.
Right, that's an important distinction.
The log linear policy class is what allows them to use the minimax theorem and ensure convergence.
And this is where the concept of a Nash equilibrium comes in, right?
Exactly. The minimax theorem asserts that a Nash equilibrium exists for the GPO problem.
So this equilibrium means there's a stable solution where the model's performance is robust across all groups.
Yeah, so it's not just about getting better at one thing, but being consistently good at everything.
Okay, that's starting to make a lot more sense now.
Now, you were also asking about the transformation itself. So how exactly GRPO incorporates preferences?
Yeah, it's a great question.
The core idea is that GRPO uses the Bradley-Terry model to map preferences to an underlying reward.
Right, we talked about that earlier too.
So every group has its own version of this preference model.
Okay, so different groups, different rewards.
Yeah, and the DPO loss function, which is used in GRPO, is used to optimize the policy for that reward.
Got it. So it's optimizing the worst case loss based on the different preferences across all the groups.
Correct. GRPO uses this mechanism to make sure no group is significantly worse off than the others.
Okay, I say that helps. It's like the groups are all competing against each other, but also working together to achieve overall performance.
Yeah, that's a good analogy.
So it's not just about language, but also opinions.
Right. It's a balancing act.
I like that. Okay, so now that we have that clarified, let's get back to our plan.
Yeah, sounds good.
So it's exciting to see how this could be used more broadly.
It is.
But for this paper, let's stick to LLMs for now.
Sounds good, yeah.
And what about the actual data sets?
Yeah, let's dive into the data sets used in the paper.
So we can get an idea of what they did to actually test the GRPO method.
Exactly. We need to look at what happened when the rubber met the road.
All right, let's do that.
So to really understand how GRPO works, we've got to look at its practical applications.
Yeah, like what data did they actually use to evaluate this method?
And the results. We need to get into the results.
Absolutely, yeah. So stay with us as we continue to unpack this a little more.
This paper is really fascinating, and we're only just scratching the surface.
All right, that's all the time we have for today.